Okay, hello everybody. This is Dr. Marston recording the lecture for week number 2 of Advanced Quantitative Research Design. I I know you've done the reading, and there was quite a lot to talk about the different types of research uh, methods that could be used in counseling and also ethical approaches. And we will certainly talk about that. I wanted for this lecture to focus more on sort of introducing the uh, advanced statistical concepts that we will be covering in this course. And there are really two. One is more prominent, but one is also um, useful as well. Um, the first is called regression analysis, and I talked about that before. Um, and so, um, and I talked about that last class, but I want to delve a little bit more into it here. And then the other one that hit me after the last class that I also wanted to introduce here, because it's advanced, but it's not very advanced. In other words, the second one I'm going to talk about is called time series design. And it's actually not advanced in terms of the statistics being more complex. It's just advanced in terms of it being a different type of concept for uh, research. So I'm going to use this lecture to introduce you to regression analysis and time series designs. And these would cover, so if by the end of this course you have a familiarity with the basic statistics that I talked about last class, which would be t-test, ANOVA, and correlations, and then um, the more advanced statistics that we will focus on here, regression analysis and time series design, if you take those five, if by the end of this course you've got the five major statistical approaches, um, you've covered 90% of your bases. I mean, as far as like having at least a basic understanding of what you will see in the research. So even though now, as I said, we will not actually be doing these statistical tests, we will just be talking about them. But if you have an understanding of all five, you will cover 90% of what you're likely to run into in the research. Also, correlational design and time series design um, kind of relate. I talked before about how regression analysis kind of relates to correlation, but time series almost even more relates to correlation. Time series design is essentially studying a phenomenon over time and correlating what you see at later dates to what you saw during earlier dates. It can be used with single subject, it can be used with treatment design. So it's a pretty useful statistical approach. So it's good to keep in mind here. But let's start with regression analysis. And I have some material here. Regression analysis is probably the most widely used quantitative method that you will see. And keep in mind, just as a reminder here, that when I talk about quantitative research methods, I often tie them in with statistics because a lot of time the type of quantitative research method that you're using relates to what statistical approach you plan to use to analyze it. Okay. Um, Now, when you do a regression analysis, uh, basically what you are coming up with in a regression analysis is you're coming up with an equation, and the equation would show you how much each dependent variable impacts, or how much each independent variable impacts on the dependent variable. And by the way, with a one thing to keep in mind, one thing to take note of is with uh, with regression analysis, the dependent variable could be called um, the explained variable, predict predictand variable, predictand variable, response variable, or and then endon excuse me, endogenous variable. So those are different terms. Usually it's either called the dependent variable or the explained variable. And then the independent variable could be called the explanatory variable or the regressor variable. Usually, the dependent variable, if a different term is used in regression analysis, is known as the explained variable, and the independent variable is known as the uh, explanatory variable or the regressor. For the sake of just consistency, I'm going to still refer to them as dependent and independent variable. So, what you what you um, are doing with regression analysis is you are coming up with a formula that shows how much each variable impacts uh, on other, uh, how much each independent variable impacts on the dependent variable. And as I said last class, one of the strengths of the dependent, I'm sorry, one of the strengths of using regression analysis is it allows you to um, measure the impact of a continuous independent variable on a continuous dependent variable. And some of the benefits of a regression analysis is it, in, it indicates the strength of multiple independent variables on a dependent variable, and it indicates which of those relationships are significant. But as far as the independent variable on the dependent variable, so you get to see the relationship, and it also shows the strength. So one of the weaknesses of an ANOVA is it shows whether the relationship is significant as far as a yes no question, but you have to do multiple tests to see how strong of a relationship each independent variable has with um, each independent variable has on the dependent variable. With a regression analysis, the equation shows how strong of an impact each independent variable has on the dependent variable. Um, Now, you could have um, I had said last class, I believe I made a small mistake. I had said last class that it's always that you have to have multiple um, multiple independent variables on one dependent variable. That actually isn't true. You can have a single independent variable and a single dependent, and that is called a simple regression analysis. That's basically a correlation, except that a correlation, you can determine whether a correlation is significant, but there are additional tests you have to do in order to determine the strength of that significance. Whereas a simple regression will show you what the strength of that relationship is. Um, what's also useful to keep in mind here is that most of the time when we talk about regression analysis, we talk about what is called linear regression analysis, which is, um, you know, that the relationship is in a straight line. Um, that it's measuring the strength of the relationship as either it goes this way, as the numbers of your dependent variable go up, the numbers on your independent variables go up, or going down, that as your measures on your independent variable go up, the measures on your dependent variable go down. But either way, it's considered to be a linear. Either the graph is going this way or the graph is going this way. You could have nonlinear. You could have um, uh, circular or a U-shaped relationship, which means that at a certain point, um, you have at a certain point you have as your independent variable goes up, your dependent variable goes down until you get a certain point, and then it starts to go back up again. So you can have nonlinear regression analysis that measures the relationship um, in more of a U-shaped way rather than a straight line. Now, I may later on go into some of the terms that you would get with the statistic, but the bottom line to start with is what a regression analysis gives you is an equation. Um, and the equation tells you, so with the equation, your dependent variable is y, and then um, each of your uh, independent variables are x. So x1, x2, x3, and then basically your formula comes out as y equals x1 plus x2 plus x3, and those x's are the um, the uh, the effect, and we can talk later about the statistics and how you calculate the effect, but the effect that um, dependent variable has on each independent variable has on the dependent variable. So x1 plus x2 plus x3. Now there is another. Um, so each x in that equation shows you uh, how much of an effect each independent variable has on the dependent variable. Now, there's also another statistic called R2, R squared, and R squared shows you how much of an impact overall all three or all of your variables have on the um, on the dependent variable. So with R2, you basically are calculating with R squared, you basically are calculating how much of an impact all your variables have on your dependent variable. So how much of your dependent variable has been explained by all of your independent variables. So that's R squared. Um, and so what you would do with your regression analysis is you would get two results from running a statistical test with your regression analysis. One is you would get a formula that would show you your dependent variable as one variable and show you how much impact each independent variable has on that dependent variable. And then what you also would get is a graph that would show you where each of your data points are, and then would show you the line, if you were doing a linear regression, that would show you the line that comes closest to covering all of those data points. And R squared would actually be telling you how close each of the how close your data points taken all together are to that graph. So R squared basically tells you how much, how close your data comes to falling in a straight line. And that shows you how close you are to explaining your dependent variable. So, bottom line is, and we'll get into more of the specifics, but what I just want you to understand is what regression analysis tells you is how close your independent variables come to explaining all the changes that you see in your dependent variable, and also tells you how much each of your independent variables um, show in terms of having an impact on the dependent variable. So, how much influence each independent variable has on each dependent variable. I'm sorry, on your dependent variable. Because you can only have one dependent variable with regression analysis, but multiple independent variables. Okay, now that's a regression analysis. Regression analysis is measuring the impact of multiple independent variables on a dependent variable. Now, let me talk about time series method. Time series method is more a measure of um, a measure of impact um, uh, uh, over time, as opposed to any sort of specific type of um, any specific type of statistic. And um, time series is seen as the alternative to what is called cross sectional quantitative analysis. Cross sectional is what most psychological research encompasses, and that's that you're measuring um, groups at specific moments in time, and you are comparing them to each other, but you are taking a snapshot of them at a certain moment in time. So, for instance, if you are measuring um, test performance and lighting, you might take two groups and in different have them take tests at in different rooms that have different amounts of light, and then and then study the difference in their test scores at the end. Those test scores, when you are done, represent a moment in time. You are getting a snapshot of their test performance at one particular moment. You are not studying their test taking ability over time. That's where a time series comes in. Um, so what you are doing with time series is you are finding a way of measuring and analyzing the impact of different variables over time. So, uh, what time series starts off with is taking repeated measures of a given behavior across time and at equally spaced intervals. So, you would take maybe tests at from this from the same group at different times, but that the times that you take the test would be equally spaced apart. Now, one of the things that can be particularly interesting about time series analysis is you could be studying a group of individuals. You could also be studying one individual. Time series analysis is often used uh, with behavior analysis, and in particular because behavior analysis can allow you to um, do what is commonly required in behavior analytic research, and that's to s- measure an individual on a certain behavior prior to a treatment being put in place, then putting the treatment in place, studying the individual um, after that on whatever variable you're trying to impact, then taking the treatment away, studying it, and then putting the treatment back in place in behavior analytic research. That would be called the ABAB approach. You measure it without the treatment, then with the treatment, then without the treatment, then with the treatment. What time analysis allows you to do is the statistical analysis of those measures over time. But you also can study a group of uh, individuals over time. So if you wanted to study the impact of treatment on a large group of individuals, you could do that. But a big key of time series analysis is that you study um, multiple measures over time, and that the distance between each point has to be the same. Now, the general rule with the time series analysis is that you take measurements at least 20 different times, and sometimes as many as 50 or more times for a good solid time analysis. And um, there are four things that you are looking for as far as the types of changes you might see in a time series analysis. And we can get into some of the statistics later on, and same with regression analysis. I'm really trying to introduce you to the concepts here. Um, as far as the actual numbers that you are looking at, and how the results are printed out, we can discuss this later. They can be a little difficult to follow, so I don't want to overwhelm you right now. Right now, once you understand the concepts, the actual statistics can be relatively um, easy to understand. But when you're looking at a time series analysis, there are basically four types of changes that you might see. One is a trend, and um, this is basically the most um, uh, um, this is the most basic type of change that you might see in a time series analysis. It basically refers to any noticeable change in the in the magnitude of relationship between the different variables. So any sort of change that you notice over time is called a trend. And basically, it would be a trend um, is um, basically it's called a trend if you have a major change that is measured in in the variable. So in other words, you're measuring from one time point to another time point, then another time point, another point, and the difference between those two remains rather steady. But then all of a sudden you've got a major change, and the relationship between this time point and another one jumps, and it continues to stay at that level or it jumps even more. So a trend would be a noticeable change that occurs um, in the data that you have collected. Now, that's notable because in part you would have to try to explain what accounts for that trend. One example might be, like I said, with the behavior analysis um, research, uh, which is often single subject. So you often have just one subject. Um, the change that you see may be related to the implementation of different types of treatment. Okay, that's a trend. Seasonality um, is when you see um, a is when you see a change occur, but then it goes away and then it comes back. Now, as I explained to you, if you're using the more complex type of behavior analysis, that might be you might see seasonality. You might see um, the change occur, and then when you take the treatment away, it goes away. But it's not always um, it's always good. Seasonality just refers to when you see in the time series data a repeated pattern of increases and then decreases in the data. So a trend would look like this, and you get, and then the data goes up, um, the and it stays up. So there's a big jump in the data and it stays that way. Seasonality would be it goes up, stays up, and then goes down, stays down, and then goes back up again. That's seasonality. Um, Cycles um, is uh, the the cycles um, uh, are like seasonality, except they don't tend to they don't last for the same fixed period of time. Seasonality comes from uh, time series when it's used like for agricultural research, and so the expectation is you're going to see these jumps at different times during the years. Cycles um, are typically used for when the explanation isn't clear or isn't the change isn't expected, and um, when they don't necessarily last, when each change doesn't necessarily last um, the same amount of time. So one change may last for longer than another. And then um, irregular variation is another change, and that's when change seems to occur, but it seems to be totally random. That's usually when it's noise. It's usually expected that that's due to some sort of extraneous variable, some sort of variable where you don't see where it's not having where the variable is one that entered in that you hadn't controlled for or you hadn't expected. So uh, that's that's randomization. So you see, or irregular variation. It's also called randomness. It's basically noise when you see sort of these random changes occur. So with time series, really the three changes that you're looking for as far as having research significance is um, is a is a is a trend where you see a change, uh, and the change may just continue. Um, Seasonality, where there's these ups and downs in terms of the changes, and they seem to occur at a pretty regular pattern. And cycle is where the changes occur, but the pattern may not always be consistent. And then the irregular variation, which is basically randomness and noise. Now, when I talk about this whole issue of measuring uh, conditions over time, I want to talk about two other terms. One is called autocorrelation. Autocorrelation. And autocorrelation refers to um, the correlation between how someone is at point two compared to how they were at point one. And time series analysis often focuses on autocorrelation as opposed to specific measures. In other words, let's say you're measuring depression. Well, doing time series analysis of depression, like measuring depression at this point and depression at this point and depression at this point, may not reveal a particularly accurate measure of what's happening with the individual over time, because the measure of depression at point three may be dependent on the level to which the person was depressed at point one. So let's say, just for sake of discussion here, um, you were doing a correlation. They gave you some sort of measure of depression, of how depressed the person was, and it rated the person on depression from 0 to 100. The degree to which the person at point one was, say, a 14, or let's say the person was a 14 at point one, the fact that at point three they're an 18. Well, one of the reasons they're an 18 is that they were a 14 at point one. So you can't really just um, take the specific measures and compare them to each other. What you're really doing a lot of times when you're looking for trend is looking for a change in the correlation between one point and the next point over. Like, how much are they correlated with each other, and does the correlation change? And that's autocorrelation. Autocorrelation is a measure by which a variable correlates with itself across different periods of time. And what you were looking for most of the time when you were looking at uh, trends, seasonality, or cycles is the degree to which there are changes in autocorrelation over time. And and when it comes to statistic, this is all autocorrelation is just a Pearson correlation. It's just a Pearson correlation of different points in time, and there's a term for it. Uh, each specific measure of autocorrelation is called the lag. And lag one is for each variable is the degree to which the lag one, for instance, of measure two would be the degree to which measure one correlated or measure two measured correlated with measure one. So that would be lag one. Lag two would be the degree to which one variable correlates with two measures before. So at measure three, lag two would be the degree to which um, measure three correlates with measure one. So it's the lag, but a lag, as far as the actual statistic, is just a Pearson correlation. It's just you have a whole bunch of them. Um, so that's the degree to which you are uh, measuring autocorrelation. You are measuring autocorrelation across the time series in terms of lags. And lags are Pearson correlations of how one measure um, correlates with a previous measure, and lag with the number after is how many measures back are we going. So lag one is um, the one right before. Lag two is the one two before. Okay. Now, the next term that I want you to be familiar with for time series is called stationarity. S T A S, I'm sorry, STATIONARITY. Now, stationary is basically um, when the mean and variance in your population and your autocorrelation remains the same throughout the time series. So basically, it's the term used for when you have no trend, no seasonality, and no cycle to your data. When it's um, when even if there seems to be fluctuation in the data itself, the autocorrelation, meaning the relationship from one measure to another, remains constant. So everybody's kind of changing at the same um, uh, at the same rate, and there's no real variability in any of the data over time. So basically, stationarity occurs when you have no real impact of any variable on your data. Um, Stationarity is a rather complex thing. It's something that we can delve into a little bit more detail later. But really, with experimentation, with psychological research, you're trying to explain the trends, the seasonality, or the cycles that you see in this time series. And the time series itself is mainly just a measure of studying autocorrelations over time. Okay, that's an introduction to regression analysis and time series analysis. When we meet on Thursday, I want to go through any questions you have about the reading, and we'll talk more detail about what was in your chapters for this week.